In this video, we're going to look at problem 3.4, which has us deal with the same bacteria and parasite populations from the last problem, but it just wants us to now graph them. So I've already brought down the table of values that we started making for the bacteria in the last problem, and I started to set up the parasite table as well, which we're going to fill in to start off this problem before we go to the graphing. So they told us in the last problem that the parasites started with 100 of them, and we figured out that the growth factor, the number that we multiply by over and over again, was 3. So that's exactly what we're going to do here. The 100 is going to be multiplied by 3 after an hour, which means that there will then be 300 parasites. After that, the 300 will again be multiplied by 3, giving us 900 parasites. Times 3 again, we're up to 2,700, and then times 3 one more time, and we're up to 8,100 parasites. Now, once we actually go ahead and graph these, I want to point out they want us to graph t comma n. So that means that, for example, t being 0 and n being 500, that is going to become the point 0 comma 500. So we'll put that on our graph. 0 is right over here, and 500 is there. And then 1 comma 1,000, 2 comma 2,000, 3 comma 4,000, and 4 comma 8,000. So there are all of our points for that bacteria population. Now we can do the same thing for the parasite population. It starts out at 0 comma 100, which is down here somewhere, and then 1 comma 300, which is still actually pretty low, 2 comma 900, 3 comma 2,700. Now we're getting up somewhere. So it's right around here. And then 4 comma 8,100. So now we're jumping way up here to just over that 8,000 mark. So when we look at these two populations, we can now see visually what is going on in those graphs. Right? They're both growing pretty quickly, and we're going to compare them in a moment. But first, there's some questions they want us to answer. So first, on the graph of n, which is the bacteria, where can we see each of the numbers that appears in the equation? Well, remember, the equation for the bacteria was n equals 500 times 2 with an exponent of t. So on the graph, where do we see this? Well, the 500 is the y-intercept. And that's not really a new idea. We're used to the y-intercept being the starting point for a graph. That kind of makes sense. The 2 doesn't show up as clearly, right? I don't actually literally see it on the graph, but the 2 is the jump from number to number. So 500 times 2 gives me 1,000. 1,000 times 2 gives me 2,000. So again, even though it's kind of hard to see, the 2 is the factor from one point to the next. Or in other words, it kind of tells me how quickly the graph grows. It's not really like a slope because it's not a straight line, but it's telling me how quickly this graph is going up and up. On the graph of p, where can we see these numbers? Well, that graph was, remember the equation, was p equals 100 times 3 with an exponent of t. So again, the 100 we can see really easily. The 100 is the y-intercept. It's showing up right over here. The 3, just like on the bacteria graph, doesn't show up as easily. What the 3 again tells us, though, the 3 shows how quickly the graph will grow. More specifically, it's what number are we multiplying by to get from 100 to the next number. or to get from 300 to the next number, or multiplying by 3 over and over and over again. So that's all the questions they want us to answer here, but I want to talk about one last thing. The growth factor, as we can see here, is actually a super important number. It's even more important than the starting number, because if you notice, the bacteria started way higher than the parasites. There were 500 parasites at the beginning, 500 bacteria at the beginning, and only 100 parasites. But, and we can see this on the table or the graph, even though they start out lower, the parasites pretty quickly, for example, by the time we get to 4 hours, are already ahead of the bacteria. And if we added more points onto this table, or if we kept graphing this, we would see, for example, if I put in 5, this would be 16,000. That's a pretty big number. But if I put in 5 over on the parasite table, this gets multiplied by 3. That would give us 24,300. So, and it's going to get even bigger and bigger as we go on to the next number and the next number and the next number. The parasite graph is growing much, much faster than the bacteria graph. It just started out a lot lower at the beginning.